In this lecture, I will continue to discuss neurotransmitters, those very important chemical signals in the brain. Every thought, sensation, or emotion or idea that we have is because of the action of neurotransmitters. Neurotransmitters set off signals that are critical for the function of the brain. Therefore, evolutionary forces have developed mechanisms to control the disposition of neurotransmitters. Let's take a look at a nerve terminal that releases dopamine. The way the brain and nerve cells work, neurotransmitters such as dopamine are synthesized when they're needed. They're not being made all the time. They're synthesized after some of the neurotransmitter is released and the levels go down. To replace the neurotransmitter that's released, new neurotransmitter is synthesized. But after synthesis, after they've been made, neurotransmitter molecules have to be stored in a protected way and away from receptors. We don't want stray neurotransmitter floating around the brain, setting off signals. For that reason, neurotransmitters are stored in vesicles inside the nerve terminal. When an action potential or nerve impulse invades the nerve terminal, the vesicles fuse with the membrane of the nerve terminal and release their contents into the synaptic space. Then, they are able to interact with receptors to set up signals in the next neuron. So the release of neurotransmitter occurs only in specific places. They're released only from nerve terminals that are depolarized, and they're only released into a specific space where there are receptors. So again, the release and the action of neurotransmitters are tightly controlled. Now, an important aspect of neurotransmission, as I've mentioned earlier, is that we have to have removal of the neurotransmitter from the receptors. For the dopamine-containing nerve terminal, this removal process is an uptake process. Dopamine molecules that are floating around in the synaptic space so that they can interact with receptors are grabbed up and pumped or transported back into the nerve terminal from where they were released. This is how dopamine nerve terminals terminate the action of released dopamine. The uptake process adds to the efficiency of neurotransmission because some of the dopamine that is taken up is re-released. The uptake also restricts the spread of dopamine. As I mentioned before, neurotransmission is a very rapid process, a process that we measure in the thousandths of a second. Any kind of disruption of the overall process can lead to some kind of dysfunction or disease. The very important thing to remember is that drugs work by altering neurotransmission. Drugs work by altering neurotransmission. Another important synaptic component that we've talked about is the receptor. Receptors are the molecular sites that neurotransmitters bind to. The neurotransmitter receptor combination is what produces the signal. There are different kinds of neurotransmitter receptors. There are GPCR or G protein coupled receptors that result in metabolic and biochemical changes in the neuron. There are ion channel receptors that result in changes in charge distribution. And there's other kinds of receptors as well. These will be discussed in more detail later.